You've seen it. I've seen it. We've all played with tools like ChatGPT and been blown away. It feels like magic, right? But it's not. It's a technology called a large language model, or an LLM. And today, we're going to pull back the curtain, crack the code, and figure out exactly how this stuff really works. Let's dive in.
This question, it just gets right to the heart of it. These AIs can write poetry, they can debug code, they can even tell jokes. And it's getting harder and harder to tell the difference. So how do they actually pull it off? Well, that's what we're here to figure out.
So here's our game plan. First, we're going to look at what these models can already do out in the wild. Then, and this is the key, we're going to translate words into their secret language, numbers. After that, we'll peek under the hood at the transformer engine that makes it all go. We'll see how they learn from just a staggering amount of text. And finally, we'll talk about their new, surprising abilities and their very real limits.
All right, first up, let's just get a feel for how deeply these new wordsmiths are already woven into our daily lives. I mean, the range of what they can do is honestly pretty mind-blowing.
And just look at how varied these applications are. You've got programmers and marketers using ChatGPT to write everything from ad copy to Python scripts. Meta has a model that can translate between 200 different languages. We talk to them all the time with assistants like Alexa. And now they're even in schools with things like Duolingo Max, which doesn't just say you're wrong, it explains why you're wrong. They're everywhere.
Okay, so that leads us to the big question. We've all heard that simple explanation, right? That all they're doing is predicting the next word. And look, on some level, that's true. But that phrase hides an absolutely incredible amount of complexity. How do you go from just predicting a word to writing a sonnet or explaining quantum physics?
The whole journey starts with a really fundamental translation. For a computer to understand language, words can't just be letters on a screen. They have to become numbers. This is the secret language, the Rosetta Stone, that makes everything else possible.
And the core idea here is something called a word vector. You can think of it like a long numerical ID card for every single word. But here's the cool part. It's not random. It encodes the word's meaning. So in this giant imaginary space, words like cat and kitten are super close neighbors, while words like cat and car are miles and miles apart.
This is a brilliant way to think about it. We can pinpoint Washington, D.C. on a map with just two numbers, right? Latitude and longitude. A word vector does the exact same thing for our word's meaning. But instead of a flat two-dimensional map, it's placing it in a space that has hundreds, even thousands, of dimensions. We can't picture that, but a computer can navigate it just fine.
And because words are now just points in space, just numbers, we can do math with them. This is where it gets really wild. If you take the location for the word king, and you subtract the location for man, and then you add the location for woman, where do you think you end up?
Queen. Bam! The model lands right on the vector for queen. This one little equation proves that these vectors have captured all these complex human relationships. Things like gender, verb tenses, capital cities, it's all in the math. This is the bedrock for everything an LLM does.
Oh, okay, so the model gets individual words. But language is about sentences, about context. So how does it handle that? The answer is an incredible piece of engineering called the transformer architecture. This was the big breakthrough that really unlocked modern AI.
So inside every layer of this model, there's this little two-step dance happening. First step is the attention step. You can think of this as each word looking around at all the other words in the sentence and asking, hey, who here is important to my meaning? Then, once it has that context, it moves to the feed-forward step, where it sort of thinks about all the information it just gathered to help predict what should come next.
Okay, let's make this a little more concrete. Researchers took a look inside an older model, GPT-2, to see how it handled this sentence. It needs to predict who got the drink. The obvious answer is Mary, but how does the AI figure that out without just repeating John?
What they found is, well, it's incredible. They found these specific little circuits. They called them attention heads, and each one had a very specific job. Some heads were name movers. Their only job was to find the name Mary and get it ready for the end of the sentence. Other subject inhibition heads specifically stepped in to block the model from just repeating John. It's this beautiful, coordinated effort, all to make one single logical choice.
So that explains how the model uses context that's right there in the sentence. But what about world knowledge, right? When you ask it for the capital of Poland, the word Warsaw isn't anywhere in your prompt. So where is it pulling that from? Well, that knowledge is stored in that second part of the process, the feed-forward layer. Researchers actually found that these layers act like a huge distributed encyclopedia. They located a specific layer that had learned a capital city instruction. So when it saw the vector for Poland, it would apply this instruction, basically transforming the Poland vector into the Warsaw vector. It was doing the exact same thing to turn China into Beijing. The facts are baked right into the network.
So we've got the pieces: word vectors to represent meaning, and transformer layers to process context and knowledge. But the final and maybe most important ingredient is just sheer scale. The reason these models are so powerful is the frankly mind-boggling amount of data and raw computing power that goes into them.
I mean, just look at this graph. It's an explosion. In only 5 years, we went from GPT-1 with about 117 million parameters. You can think of those as knobs the AI can tune, to GPT-4, which is estimated to have over 1 trillion. And every single one of those massive leaps in size brought a huge leap in what the model could do.
But that growth comes at a staggering cost. Making these models bigger requires exponentially more computer power. Get this, training GPT-3 took an estimated 300 billion trillion calculations. That is an astronomical number, and it's exactly why only a handful of massive companies in the world can actually afford to build these things from scratch.
Okay, so what's the payoff for all that data, all that computation? This brings us to our final section, the really surprising things that happen when you scale these models up, and the big debate about what these machines are actually doing.
Something really weird happens when these models get big enough. They start doing things that nobody explicitly trained them to do. The researchers at Microsoft were so blown away by GPT-4's abilities that they claimed it showed sparks of artificial general intelligence. These unexpected skills have a name: emergent abilities. So what kind of abilities are we talking about? Well, things like chain of thought reasoning, where you can see the model literally talk itself through a complicated math problem step by step. Or, and this one is wild, it's starting to show signs of what psychologists call theory of mind. In one test, models could figure out that if a person saw a bag of popcorn labeled chocolate, that person would incorrectly believe there was chocolate inside. That's a reasoning task that stumps a lot of young children. And all of this has led to this huge, almost philosophical debate. On one side, you have people who say these things are just stochastic parrots, incredibly complex mimics that are just remixing text they've seen without any real understanding. On the other side, people are starting to wonder if we're seeing a new kind of alien intelligence, something that can genuinely reason, but just in a way that's totally different from a human brain. The experts are completely divided on this. And that's really the thought I want to leave you with. We have created machines that can use language, our most human creation, in ways that we often can't distinguish from our own. So maybe the real question isn't just about their intelligence. Maybe it's about what their existence reveals about our own. What does this all tell us about ourselves? Thanks for joining me.